got this thing in front of you. It says determine whether each solid is a polyhedron, then identify the solid. If it is a polyhedron, name the base, faces, edges, and vertices. Okay. All right, so it says a solid with all flat surfaces that enclose a single region of space is called a polyhedron. And I guess they're giving you some examples of that down here or not.
Yeah.
Not sure here. Pyramid has a polygon base and 3 or more named by the shape of their bases. Okay. So what do you think here? What do you see? Is a flat surface enclosing a single region of space for the first one?
I think it is a polyhedron.
It is, although it's a little, I wish they would have started out with a nice one, because the question is, well, is the curve, is this sort of this triangular curve thing, is it a flat surface? It is if you like lay it out on the ground. And but no, this one is not. I just looked this up here because I have not seen this in a while.
Oh.
So that, but it, all right. Why did they start with that one? Anyway. Okay, it's got to be a solid with all flat surfaces. So an example of a polyhedron would be like 3 and 4. You're looking for rectangles, triangles, circles are somewhat okay, but this one is not.
Yeah.
I don't know why they're starting out with ones that are not, but that's the case here. Okay, sphere. The sphere is the fun one. You can't make it into any flat surfaces. This is also a big no.
Oh wait, don't we have to
Yeah,
I mean, identifying the solid, I would just say like a cone.
Cone, sphere,
and then if it's a polyhedron, oh, okay.
Yeah, the rest of it is if it's a polyhedron, which is why I'm not sure why they didn't just give you one to start out, but
yeah,
I didn't make this up.
Give me 1 second.
Yep.
So yeah, sphere, not a polyhedron.
Same with the cone, same with the cylinder. So there's only 3 that I think you'll see here: cone, sphere, and cylinder that are not polyhedrons.
Yeah. Anything with like round.
Yeah, because you can think of it as if you laid it down, would it roll away or start rolling? And a cone would, it would sort of go in a circle. Sphere would roll. Cylinder would roll if it's placed on the non-base. All right, 3 is something, okay? And they actually give it to you in the picture, but you look for what's the face that is extended. In this case, there's a pentagon that is extended. And the other way to kind of think about it is like, how could you slice this and always get the same shape? You think of like a stick of butter, or if you cut up fruit, like vegetables, there's a certain way to cut certain things where you always get the same shape.
Yeah.
And so that word that is the modifier, the adjective of the prism. So this is a pentagonal prism.
Oh, okay.
Yes.
Yeah. Makes sense.
Okay. All right. So now that we know that it is, we can say yes to polyhedron. We can now analyze the rest of it. Bases, faces, and edges, and vertices. All right, so there's actually a ton here, so we'll have to do this kind of slowly here. Let me grab the picture one more time. The base is generally the thing that it sits on.
Yeah.
And it's and more specifically though, it's the front face. is typically what I think of as the base is the thing that it sits on. You could argue that it's sitting on one of these rectangular regions, but I would almost like you imagine it flipped up. To me, the base that it would sit on is this pentagon here, PWXYZ. And it could also be the other one. The
Could
one
it could it also be PRQW?
PRQW. So yes, but typically it's the one that it sits on, meaning the one that's the front face that's extended. I would go defer to your instructor for what they want here, because there's kind of some gray area. To me, it's always the one that it would typically sit on, meaning the face that's extended.
Yeah.
I'm not sure. I do know that it could be the other one as well, because to your point, if it's PRQW, well, then it could be XWQV. I mean, who's to
Yeah.
say what this is actually resting on? We can't tell. So that might be something to get clarity in class. QRSUV, like that. The faces are a little bit easier. The faces include everything that is a flat surface.
Okay. So like YXVU.
Yes.
Okay.
Like any of the combinations of 4 letters, you got a lot to write down here. YXVU. So you typically start somewhere and work your way around it. CY. It's kind of busy work. And then you also have, once you get those 5, you also have the 2 bases to include in your list. There's actually some language here to help clarify the bases here. The bases are connected by parallelogram faces. And what that means
Oh.
is that they are not going to be the rectangular the parallelograms here. It's the pentagon because it's connected by a parallelogram face.
Got it. So then
Vertices, that's the easiest one. It's just all the letters.
Yeah.
Let me know when we can move on to the next one, please.
We can move on.
All right, number 4. This one is going to be a little bit easier. The bases are the triangles. And you can see that the triangles are parallel to each other. And they're connected by a parallelogram.
Uh-huh.
So it would be triangle, ABC.
Triangle. D, F.
Yes. The faces come next. They include the bases, but they also are the parallelograms.
Cool.
Vertices, all the letters again. So, all right, hopefully the next ones will be a little more.
Oh wait, what about the edges?
Oh, we didn't do edges for either of them, did we? Okay, I missed that. Let me go look here. Oh boy. So edges are the lines, the connecting lines. So there are a lot of these. In the previous one, it's any two connected letters that you might see. I apologize. And these are just hard to sort of like, you almost want to sort of say, okay, I'm going to go all the way around the pentagon and then all the way around the other pentagon and then connect them to get them all.
Yeah.
So it's
So
like P to,
YU,
yes,
XV.
yes, there's the full list here. Should be a little easier to do the edges. You have more vertices, there's fewer edges.
Cool, got it.
All right, so we go on to.
Oh yeah, the triangle now. Okay, we can move on to 5 now.
All right, so I don't see a 5. I see, maybe I'm not.
Oh yeah, sorry. I like A, I guess.
Yeah, so A is an example, which we can go through. Same with B and C. or we can go right down to the exercises. What would be best for you?
Sounds good.
I go to the exercise or go through the example?
Uh, Actually, let's go through the example real quick.
Okay. All right. So the let me step back from giving you everything. Sometimes seeing it all at once is not very helpful. We're actually going to start with volume. I think volume is more straightforward. Volume is the area of the base, 1/3 of it times the height. Okay, and do they show that here? Your teacher uses a different formula. Why does your teacher have 13 BH? Okay, I don't understand.
13 base times height.
Yeah, so the area of the base is this square. The square here is 24 times 24, and the height is 5. So you'll
It's
find
the slanted.
this
Right.
one goes straight up and down. That the 13 has nothing to do with. I mean, that is another way to do it, but I don't know where that formula is coming from. 13 BH slant height BH. That's an odd formula to use. I've not seen that in a long time. The one I'm giving you is the more standard one that you'll see.
Okay.
Because the base is always a nice geometric shape, like a square, rectangle, triangle, prism, etc. So you can do it this way. You can do it another way. You will get 960 centimeters cubed for that.
So the 1/3 a base times height is the easier one.
Well, it works for a variety of things. It's more generalized than the thing that you're given there. It works for pyramids and cones.
Okay. Why is there a big B for base?
These exercises use B to represent the area of the base. So that your instructor is saying,
area of area.
Yeah, base times the height, and the instructor meant 1/3. They wrote 13. That's what that is. You can ask about that tomorrow if you have class.
I thought it was talking about 13 is like the
It is the
slant.
slant height. I think that was just a
Coincidence.
coincidence. Yeah. Okay. Surface area. So the surface area is divided into two things. There's the lateral surface area, which is kind of think about like what you would paint. And then the total surface area is this stuff around the edges.
What's the difference again?
Okay, so this is maybe not a good. So there are 4 triangles. Do you agree with that?
Yeah.
That's what's called the lateral area. The base is a square. When you add these together, that's the surface area.
Uh-huh.
So you can think of the surface area as all the faces, but the lateral area excludes the bases. Okay. So to find it, there is a formula, but you can also sort of say, okay, well, I've got 4 triangles. How do you find the area of a triangle? 1/2 base, the base is 24, the height is 13. So inside parentheses here, 1/2 24 times 13, that's the area of one of these triangles. But there's 4 of them because you're going all the way around.
Okay.
Plus, you need the area of the base, which is 24 times 24.
Got it.
So I think if you do the calculation here, you will get 1200. You're welcome to try that if you want. So this distinction though between the lateral area and the surface area, it's a big one. It's one that I think students often miss. And it's more of an issue in like B and C, but your exercises down there at the bottom, they require you to differentiate between the two.
Mm-hmm.
So do you want us to go through example B, example C, or do you want to go to an exercise? What would be best?
Let's just start exercise 1.
Okay. All right, so you got a little legend guide there at the top. It tells you to look at the base. The base is the thing it sits on, and it has to tell you that here because it could actually sit on any of the 6 sides potentially.
Yeah.
Okay. So when it says P of the base, they're asking about the perimeter of the base. They're asking for you to figure out the distance if you go all the way around the base there. So that's 10 plus 4 plus 10 plus 4, which is 28 inches.
Yep.
All right, so the base is the literal area of the base. B means the area of the base. That's 10 times 4. That's 40 inches squared.
Mm-hmm.
All right, so they give you formulas for why do they call it H? Height of the prism. Okay, so the height of the prism is 4 in this problem. That's just the vertical distance. Sometimes it's better seen there. All right, lateral.
How'd you get the height?
It's just given. It's maybe not drawn well, but it's actually this dimension right there.
Oh.
I usually prefer kind of on this back line there.
Okay.
All right. Now the total surface area is, and they give you a formula for this, which I don't like, but it's the perimeter of the base times the height plus 2 times the area of the base. Okay, and I find this to be very unclear because it's how does this even work? But it is true. It is true.
Perimeter times the height.
Yep.
Plus 2 times the base.
Yes. Like if I were in charge, I would never allow you to use this formula because it's very unclear, but it does work. The lateral surface area is just the pH part of it. And the reason is 2 times B is the base on the bottom and the base on the top. That's the part that's excluded from the lateral surface area. The lateral surface area is just like what you would paint. You can imagine painting it. You just paint around the 4 walls on the side.
Yeah.
Imagine you're not painting the ceiling or the floor. Okay, so your perimeter is 28. Your height is 4.
So 112 is the lateral surface area.
Yes.
So inches, square inches.
Yep.
And then, so it's the area of the base.
2 times B. B is the area of the base, which is 40 in this problem.
Okay. $192. $192 square inches for TSA.
Yes. Transportation Security Administration, right? I don't know. I don't know why you shorthand something like this. This is not typically shorthanded to TSA, but
yeah,
nevertheless, that is what it is. The thing they didn't even ask you for here is volume, which is length times width times height. But you know.
Yeah, I remember that.
All right. Do you want us to go into number 2?
Yeah.
Okay.
So, oh man, is the 4 centimeters referring to the radius, I'm assuming, or the
Yes.
circumference?
Yes. And it should be a little bit clearer, but it is the radius. So the base this time is the circle. They're not telling you, but the circle is the only thing that it sits on. Because if it's sat on the I don't know what to call it, the lateral edge, it would roll away.
Yeah.
All right. So the exact circumference is 2 pi r, which is 2 pi times 4. Or 8 pi. That's what they mean by exact. And they want units, 8 pi centimeters.
Got it.
Same thing with the exact base area. That's pi r squared, which is pi times 4 squared, or 16 pi centimeters squared.
Okay.
All right. And then the height here, height is 9 centimeters. Okay.
Yep.
So the lateral surface area, it's got a formula here.
Is
I believe it's perimeter times height. And perimeter in this case refers to the circumference.
oh, so 8 pi times 9.
72 pi centimeters, excuse me. And then the exact total surface area is the perimeter times the height plus 2 times the base. And they're calling B here the exact base area.
Seven 2 pi centimeters. And then the exact surface area would be P times H plus 2 times the base.
Yes.
So 72 pi plus 2 times 16 pi. Squared, right? Or did we just put the centimeter squared at the end?
Yeah, centimeter squared goes at the end. You add them together.
Oh.
Looks like it's 104 pi. And then the last little piece there is to go to your calculator and estimate.
Cool.
Right. Let me know if your brother's going to join on this link, or he can use the one he's been using, or his new one for both lessons, but I just need to know that for going forward.
Yeah, I texted him. I think he's just gonna use the one that